Hey guys, I want to show you how to do the math practice assignment that you had for homework. So I'm going to bring up Equatio and we will edit math. We're going to start by rearranging the equation for mass and solving f equals ma for mass. So we start with f equals ma. And we need to get m all by itself on one side of the equation. So I'm going to divide both sides by the a. That way we'll cancel out the a's and we'll just have m by itself. What I do to one side of the equation, I have to do to the other. Now I'll simplify it. So we have f divided by a is equal to mass. And I'm just going to flip it around. So we have m equals f over a. And now I can insert that. There. All right. And then we're going to do the same thing for a, except this time we're solving it for a instead of m. So to get the a by itself on one side of the equal sign, I have to divide both sides by the m this time. That way the m's will cancel. And we just have a on one side. I'm going to flip it around right away and say a, what we're solving for, is equal to the force divided by the mass. Now we have all three equations that we could possibly use in this assignment to solve for anything we need. We have the equation solved for force, we have the equation solved for mass, and we have the equation solved for acceleration. So, number 2, when on a bike, a biker has a total mass of 70 kilograms. If he pedals with a force of 95 newtons and encounters a frictional force of 15 newtons, what is the net force? So we need to just add these two forces together. So the F net is equal to those two forces, keeping in mind that these forces are in opposite directions. So adding them is actually subtracting, because that 15 newtons of friction is going to counteract some of the pedal force, and we will end up with a net force that's smaller. So 95 minus 15 is 80 newtons, and that's our net force. That is the force that we will use in part B to find the acceleration of the bike and the rider. So let's do our list of knowns. The given information, we know that the F net is 80 newtons. We also know that the biker has a mass of 70 kilograms, and we need to find out what the acceleration is. So that's what we don't know. Now, let's plug our numbers into the equation. We're using the version of the equation that has been solved for acceleration. So A equals F over m. I'll put numbers into that. A is equal to the 80 newtons of net force. 80 newtons divided by the mass, 70 kilograms. And so we'll have 80 divided by 70. And then take out my calculator and figure out what that is. And we should have an acceleration of 1.14 meters per second. And that's the answer. Okay, and the next problem. Oh, it's on. I don't like that. Move it to the next page. Okay. This time we have a bike racer accelerating at 6 meters per second, so we know the acceleration. And this biker has a total mass of 110 kilograms. And we need to find out how much force they have when they pedal. So this time, we'll be using F equals ma. F equals, force is what we're looking for. Mass is 110. So 110 kilograms times the acceleration, 6.0 meters per second. 0.0. And then we just have to multiply them together. F equals 110 times 60, 6,600 newtons. And that is our answer. Insert math. And I'll just put F equals 6,600 newtons. Done. All right, number 4, we have to figure out what the acceleration of a biker is. The biker is applying a net force of 140 newtons. The biker has a mass of 45 kilograms, and we need to figure out what the acceleration will be. We'll use that equation, solve for acceleration, which is force divided by mass. Substitute numbers in that. The force is 140 newtons. Divide that by the biker's mass, 45 kilograms. Insert that. Use the calculator to find 140 divided by 45, and we get 3.11. Oops. Acceleration is 3.11 meters per second. There we go. All right, number 5, we have a bike racer accelerating at 5.5 meters per second. They have a total mass of 50 kilograms. How much force do they apply to the pedals? And we're assuming that there is a frictional force that is equal to 20 newtons. So we have to take that into account. First, we're going to find out what the net force is. That F equals ma gives us the net force, but then we need to keep in mind that there's a frictional force that is applying 20 newtons in the opposite direction, so the bike rider has to overcome that friction and then also accelerate the bike. So let's figure out the net force. F net is equal to the mass of the biker, 50 kilograms, times the acceleration, 5.5 meters per second squared, and then that will give me a net force of 275 newtons. We're not done yet. Now to figure out the force that the biker applies. Actually, I'm just gonna put net down here because that way we are differentiating between the different forces going on here. The net force is equal to the force of friction plus, the force that the biker applies, so I'm going to call that the applied force, plus the frictional force, while keeping in mind that friction is in the opposite direction from the applied force. So substitute our numbers in. We have 275 newtons for the net force. The applied force is what we don't know. And we're adding to that the frictional force, which is actually in the negative direction, so minus 20 newtons, or plus a negative 20 newtons. So now I need to add 20 newtons to both sides to get that 20 newtons of friction over on the other side of the equal sign so that we know what the applied force will be. So if I add 20 to that, then this will become 295 newtons is equal to the force applied by the biker. That was a long one. We'll insert all of that, and then I'm just going to rewrite it as our answer. Force equals, force applied by the biker is equal to 295 newtons. All right, number 6. A car accelerates with an acceleration of 12 meters per second, and the car has a mass of 500 kilograms. If it is pushing against a frictional force of 1,000 newtons, what is the force of the engine? Okay, so this is similar to the biker question, where we will figure out the net force required to accelerate the car at that rate, and then take into account the frictional force in order to figure out the engine's force. So, let's figure out the net force. Force net is equal to the mass times the acceleration, and that will give us a net force of 600 newtons. No, 6,000. 6,000 newtons. Then, that net force is equal to the force of the engine plus the force of friction, keeping in mind that the frictional force is going to be in the opposite direction from the others. Ooh, did not mean to do that. That's not cool. Friction. Okay. Now, net force is 6,000 newtons, and that's equal to the force applied by the engine, plus the frictional force, and that is in the opposite direction. So that's 1,000 newtons. Now, the engine has to overcome 1,000 newtons before it can then accelerate the car. So it's going to include both of those. Add 1,000 to both sides of this equation, and we get 7,000 newtons is equal to the force of the engine. There's our answer. I'll just rewrite that. Okay. We have number 7. A car is generating a net force of 3,500 newtons. The car has a mass of 1,500 kilograms. What is the acceleration? So we use the equation solve for acceleration. That's force divided by mass. So our net force is 3,500 newtons divided by the mass of the car, which is 1,500 kilograms. And our acceleration is 3,500 divided by 1,500. We get an acceleration of 2.33 meters per second squared. I put it in the wrong place. Oh, there. And then I'm just going to rewrite it. So our acceleration is 2.33 to 0.33 meters per second. And number 8. When a bike rider and a bike have a total mass of 90 kilograms, he pedals with a force of 45 newtons and encounters a frictional force of 45 newtons. This would be the force applied. The biker applies 45 newtons. There's a frictional force of 45 newtons. We need to figure out what the acceleration is. Okay. Now, in order to find acceleration, remember, acceleration is equal to the net force divided by mass. And the net force is not given, but we are given the applied force and the frictional force. These two are in opposite directions. So the biker is pushing the bike forward and friction is slowing it down. So that means that the net force will be 45 newtons of applied force minus 45 newtons of frictional force acting in the other direction. And then we will divide that by the mass, which is 90 kilograms. That net force is 0. 0 divided by anything is 0. So this biker is not accelerating. The biker is going at a constant speed, and their acceleration is equal to 0 meters per second. That's it. I didn't mean to do that. All right. And that's the last question.